Ratio test is a theorem. So if we have a series and we want to know whether it converges or diverges, and we don't care if we have positive, negative terms, maybe some of them are negative, maybe infinite number of them are negative, and maybe infinite number positive, so it will work for everything when it works. So, and suppose that the following limit exists. We would say rho, this is a Greek letter, is equal to the limit n goes to infinity a n plus first divided by a nth, and also we will take the absolute value of that. Okay, the theorem says the following. If rho is less than 1, that series converges. It also says if rho is greater than 1, then the series diverges. And then it says, guys, if rho is equal to 1, I don't know. It could be converging, it could be diverging. So you would say the test is inconclusive. And you will need to pursue other options to find out whether the series converges or diverges. For example, this whole ratio test was inspired by geometric series. Remember geometric series? Let me not use A, let me say geometric series is c times r to the nth from 1 to infinity. Let me compute rho for the geometric series. So rho is going to be the limit, n goes to infinity. Okay, c r to n plus first divided by cr, an absolute value of that. Oh, cr to the nth. C cancels out, r to the nth cancels out, and what I have is only limit of r that does not depend on n. So what I get is just absolute value of r, where r is common ratio. And if we do know that if absolute value of r less than 1, geometric series converges, right? So these two features are in the agreement, right? Now we know that if absolute value of r greater than 1, the geometric series diverges. But we also know if for geometric series the rho test is inconclusive, we kind of still know that it diverges because geometric series is more known to us than any other series. So yeah, that we know independently. So in case of geometric series, when rho is equal to 1, it will still diverge. Okay, now I have to remind you that I posted Professor Fowler's notes, and I want to use them now. So I want to use page 18, where she shows us which examples, let me focus them better, which examples are useful for to practice ratio test. Okay, prove that the series 2 to the nth divided by n factorial converges. So every time you see n factorial, ratio test is really, really good because factorials cancel out fantastically. Okay, let me write a n plus first is going to be 2 to the n plus first divided by n plus first factorial. Now, n plus first factorial is going to be 1 times 2 times and so on times n times n plus 1, right? Notice that this is n factorial. So we will have n factorial times n plus 1. Okay, so this is lovely. So now that we are going to use it when computing rho. So rho is going to be the limit n goes to infinity, a n plus first divided by a nth. So we get the limit n goes to infinity. Upstairs we just have full-blown a nth plus first. Okay, so 2 to n plus 1 divided by n plus 1 factorial, and then divided by a nth. So it's the same as multiplied by flipped a nth, right? So I will put n factorial here and 2 to the nth here. See, I'm flipping this guy. Okay, so I will have the limit n goes to infinity. Now I'm cancelling 2 to the nth, and I'm left with just 2 to the first here. Okay, 2. Now I will write n plus 1 factorial is n factorial times n plus 1, and I will have times n factorial, right? So n factorial cancels out. I can drop also the absolute value notations because everything is positive here. And so I end up with a very lovely expression. 2 divided by n plus 1 definitely goes to 0. 0 is less than 1, so what we got is rho is less than 1, therefore the series converges. Series converges by the ratio test. Okay, so that was relatively painless. Let's see what example 2 is bringing us. When you have 2 to the nth, both ratio and root tests actually might work, but we didn't study root test yet. Okay, so a n plus first is going to be n plus 1 squared divided by 2 to the n plus first. So we would say rho is equal to the limit n goes to infinity. What people forget is that it's a n plus first divided by a nth. Sometimes people flip them. And also it's a very good question to ask on true-false test. So let me put a star here. Okay, so we have a n plus first n plus 1 squared divided by 2 to the n plus first divided by n to the a nth, and we just go flipped. So times we have 2 to the nth on top and n squared on the bottom. So this guy cancels out, and we end up with 1/2, right? 1/2 we can carry outside of the limit sign. So I would say 1/2 times the limit n goes to infinity, n squared plus 2n plus 1, I open the parentheses, and divided by n squared. So we end up with 1/2 limit n goes to infinity, 1 plus 2 by n plus 1 over n squared, which is equal to 1/2 times 1, which is equal to 1/2, n is less than 1. Therefore, the series converges.